today's goal of this lecture. Today I will see some question of CSIR net about ring theory. Today actually just review part. First question, which had come CSIR net 2025 February exam. The question is, let Cxy be the polynomial ring in two variable over C. Then for which following ideal I, the quotient ring Cxy modulo I is not integral domain. Option 1 I equal to xy, option 2 I equal to x plus 1 y, option 3 I equal to x square plus y square, and option 4 I equal to xy minus 1. For this there exists two results will be used. First result, a quotient ring R mod I is an integral domain if I is a prime ideal. Second result, an ideal generated by irreducible polynomial in Cxy is prime. Cxy ideal generated by xy. This is isomorphic to C, and C is an integral domain. So when I equal to xy, then here the question about which is not I equal to xy. When I equal to xy, then this is integral domain. So option 1 is a wrong option. Option 2 I equal to x plus y. Cxy ideal generated by x plus y. This is isomorphic to C, and since C is integral domain, so Cx also integral domain. So this is also wrong option. I equal to x square plus y square. This is, we can write I equal to x plus iy times x minus iy. This is the reducible polynomial in Cxy. So notice, an ideal generated by an irreducible polynomial in Cxy is prime ideal. Since this is the reducible polynomial in Cxy, so this is not be prime ideal. So since this is not prime, so this is not integral domain. So option 3 is the right option. And option 4 I equal to xy minus 1. Obviously this is irreducible polynomial in Cxy. So in Cxy this is be the prime ideal. That means Cxy modulo I is isomorphic to integral domain. So this is not the question about not integral domain. So this is also wrong option. Next example, which had come CSIR net December 2024 exam. The question is, which of the following statement is true? Option 1, the ideal 2 Zi is maximal ideal in Zi. At first I will show, is 2 Zi is maximal ideal in Zi? At first, see, we all of us know the definition of maximal ideal. Maximal ideal. An ideal I which be the proper subset of R and I not equal to R, then if I contain the ideal J where J contain R, then that imply either J equal to R or J equal to I itself. That means there exists no proper ideal such that I contain in this proper ideal. Then I is called maximal ideal. We all of us know, in my previous video there exist many video in my playlist about maximal ideal, about many question about my maximal ideal which had come in different comparative exam. ZI. Here the question about 2 ZI. ZI mean we all of us know this is the set containing A plus IB where AB belongs to integer. And here the question about 2 ZI. 2 ZI means ideal generated by 2 which is contain obviously ZI, and this is actually the set is 2 the set is look like 2 times A plus IB where AB belongs to integer. Here notice 2 equal to, we can write 1 plus I times 1 minus 1 I, but neither 1 plus I contain the ideal generated by 2 nor 1 minus I is contain ideal generated by 2, but 2 can be written as product of 1 plus I times 1 minus I. We all of us know definition of prime ideal. If P belongs to AB, then either P belongs to A or P belongs to B. Then P is called prime ideal. But this is not satisfied. So 2 is not prime ideal in ZI. And in CRU, every maximal ideal is a prime ideal. That means since 2 is not prime ideal, so this is not be maximal ideal. So option 1 is a wrong option. I hope my all viewers have understood clearly. Another method, an ideal I which is not equal to R of a ring R is a commutative ring with unity is maximal ideal if the quotient ring is a field. That means if R mod I is isomorphic to field, then I is a maximal ideal. So another method is ZI and ideal is 2 ZI. If this is isomorphic to field, this is isomorphic to Z to I. Okay, and we all of us know this theorem. ZI modulo NZI is isomorphic to ZNI, and ZNI is a field if n is congruent to 3 with modulo 4. Okay, here 4 does not divide 2 minus 3 equal to minus 1. Here 4 does not divide minus 1. So Z to I is not a field. So since this is not a field, so this ideal is not maximal ideal. This is another method. Second, the ideal x CXY is maximal in CXY. This is also very easy method, we all of us know. Here ideal x CXY means ideal generated by x. We all of us know x CXY, which is actually equal to ideal generated by x. This is contain in ideal generated by xy and which is contains cxy. That means there exists one proper ideal J. So I is not maximal ideal. Okay, this is one method. So option 2 also wrong option. In CXY, the maximal ideal is from as ideal generated by x minus a times comma y minus b for all AB belongs to complex number. Here CXY modulo ideal generated by x, this is isomorphic to CY and CY is not a field. So this ideal is not maximal ideal. Okay, I hope my all viewers have understood clearly. Oh wait. Next option, at first I will see option 4. The ideal root 2 minus 1 z root 2 is maximal ideal in z root 2. This is also same method. The ideal root 2 minus 1 z root 2 means ideal generated by square root of 2 minus 1. Here z root 2 means a plus b square root of 2 where ab belongs to integer. We all of us know this is. If any ring contain unit, then this ideal is actually the whole ring. We all of us know. And here root 2 minus 1 times root 2 plus 1, this is actually 2 minus 1, this is means 1. And we all of us know definition of unit. In a ring, A is unit if A dot B equal to 1 equal to B dot A. That means root 2 minus 1 is unit. So since these ideal contain unit, so this is actually whole ring z square root of 2. But in maximal ideal, we all of us know definition of maximal ideal. I always must be proper ideal. But here this ideal is not proper. This is actually the whole ring z square root of 2. So this is not maximal ideal in z square root of 2. So option 4 also wrong option. Option 3, obviously option 3 would be correct because there is only one option. The set of all polynomial whose coefficient add up to 0 is a maximal ideal in CXY. At first think oneself, then show my solution. Ideal is look like the set of all polynomial whose coefficient add up to 0. That means ideal is look like an x to the power n plus an minus 1 x to the power n minus 1 plus the up to a naught, such that an plus an minus 1 up to a naught equal to 0. Since all coefficient is at up to 0, and this is nothing but if this is fx, then this is f of 1. And we all of us know in fx ideal such that f of a equal to 0 for some a is maximal ideal in fx. So here obviously this is look like f of x belongs to cx such that f of 1 equal to 0. Obviously, this is look like this type, and this is maximal ideal in CXY. So, option 3 is a right option. I hope my all viewers have understood clearly. This question is very conceptual and very useful for any competitive exam. Okay? Well, today I will stop here. In my next video, I will discuss again some question about ring theory as a review. Because ring theory, this concept is actually very important for any competitive exam, also for higher study. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.